Video we'll be talking about solving inequalities, intersection, and union. So again, let's start with the basics. Remember that solving an inequality is almost exactly like solving a linear equation or any other function, except we have to keep one thing in mind, and we'll get to that in a minute. So just like with any kind of inequality, we're going to subtract, oops, let me get that pencil going here. We're going to subtract 8 from both sides. We're going to have 4x is now greater than or equal to 2, excuse me, goodness. And then dividing both sides by 4, I have that x is greater than or equal to 1/2. Same thing over here, we're going to subtract 12. So I have a negative 5x is greater than or equal to 45. And then we're going to divide both sides by negative 5. Now this is the one exception that we have to remember, is that when we have both sides divided or multiplied by a negative number, that means we have to, oops, it's going to be negative 9, excuse me, I forgot to write that. It's going to be negative 9. We're going to switch the sign. So again, a reminder that when we multiply or divide both sides by a negative, we're going to be switching the signs. So let's again do this last one. So again, I always go in the direction where I'm going to have a positive x if I can. Oops. So we still have the negative 9. Don't forget to carry down the sign. And this is going to be x. This is going to be 30. And then what we're going to do is we're going to add 9 to both sides. So we have x is greater than 30. So we have all these values, and now what we have to learn is how we're going to represent them. So one of the things that when we look at number lines, we usually typically set up our number lines with the value that we're looking at. So this value is going to be at 1/2. I can have 0 and some other values over here just to help me out. This value is here going to be at 9, so I can start at 0, 5, and then 10. So my number 9 is going to be here. And then this one is going to have 30. So we can start, 10, 20, and 30. So I know my value is going to be here on the number line. But one of the things I want to talk about is we're going to be switching. So open dot typically means, we see that on a number line, where we see that means greater than, less than, and a closed dot usually meant the greater than or equal to, less than or equal to. But what I want to talk about is the fact that parentheses mean the same thing. So we are actually going to start relating the open dot, closed dot to the bracket and parentheses. So when I see a bracket like this, that means the same as the greater than, less than, greater than or equal to, less than or equal to, or the closed dot. When I see the values without the equal to, we're going to have parentheses, same as the open dot. All right, so what does that look like? So let's put that on the number line. So I'm going to change over to a new color. And what we're going to do is we're going to talk about the fact that this means x is greater than. So that means it's going to be, x can be 1, x can be 2, it can be 3, it can be anything. But it's going to start at 1/2, and it's going to be shading everything in that direction. So remember that greater than, again, the sign pointing towards the x, is going to be the values bigger than. And then what we're going to do, because it's not, because it is equal to, excuse me, that we're going to put a bracket on the number line. You get that matched up right there. Okay, so that's the way we're going to represent the number line. And then on this one, we have 9, and it says x is less than or equal to 9. So again, being less than or equal to, we're in this territory. So I'm going to set up the bracket, and I want everything to be less than 9. So it can be equal to, 6, 7, 5, 0, negative 4. So we're going to shade everything to the left. Left is less than, right is greater than. So then looking at this one does not have an equal to, so it's going to be everything greater than. So it can be 40, it can be 50, it can be 100, it can be everything to this direction. But this one does not have the equal to, so it's going to have the rounded. Now why am I switching over? Because that makes the difference between set builder and interval notation. So not only can we represent that inequality based on based on the number line, but we can also do the set builder versus interval notation. So let's talk about set builder first. For me, that's the easiest, because what it is, and I'm going to put it below each one, what it is basically restating the inequality. For example, if I wanted to make a set, tell me what numbers work. Well, I know that anything greater than 1/2, so it can be 1, it can be 6, it can be 12, it can be anything off in that direction. But a way of kind of giving that formula is saying it's all x's such that, and that's just mathematical shorthand, such that x is greater than 1/2, which basically is stating the inequality all over the time. So for set builder notation, all you have to know is this shorthand. You're going to do the brackets for all x such that, and then you're going to state the inequality such that x is less than or equal to 9. Over here, set builder, it's all the x's such that x is greater than 30. So building a set builder notation, and again, knowing the difference between one and the other, is simply just stating the inequality and just kind of defining it within this map. The interval notation gives us the start and the end of the interval that fills up this entire thing. So if I look at this particular graph, I start here at 1/2, and then I go off all the way into infinity. So we're going to say that I start at 1/2 and I end at infinity. This one says, well, I'm here at negative, it's negative infinity all the way here, and then I stop at 9. But the one thing is we have to have brackets, and this is the cool thing. This is why I emphasize the bracket or parentheses versus the open dot, closed dot, because the same bracket that you have on the number line is the same bracket that you have on your inequality. Again, the same bracket here is the same bracket that you have on your interval here. The one thing is we can never have anything equal to infinity, so infinity or negative infinity will always, always, always have a curved bracket because we can never be equal to infinity. But looking at this next one again, it looks like I started at 30 and it goes up onto forever, so it's going all the way into infinity, but this one has a rounded bracket, so those are the two brackets I have. I'm always going to have the interval match the brackets or parentheses that I put on my number line. As always, there's more help and more practice in class, but we're going to move on. The next video is going to be on intersection and union.